Hello and welcome to our next lesson in circles, arc angle relationships. We've covered pretty much a lot of different angle measures like inscribed angles, central angles, arc measures, arc lengths, things like that, and we've talked about tangent lines. To add to that, we are adding a new term, a secant line. A secant line is helpful and useful to know. Especially so it's not like a tangent line. A tangent line intersects, as we know, at a circle at exactly one point. A secant line would be a line that intersects with a circle at 2 points. So it is a line that intersects a circle at 2 points. So for instance, if I were to draw a circle here, let's call this circle K, and I could draw this particular line. It looks like it could be a chord, and yes, technically, if I call this A and B, AB could be labeled as a chord, but AB could also be labeled as a secant line. Okay, so we could here say AB is secant to circle K. Okay, and when we have secant lines, it definitely creates its own arc, but what we're covering today is an intersection of either secant lines or tangent lines. So when you think of an intersection, we think of two lines that meet at one particular point. So I'm going to put this one in pink. For instance, what happens if I were to draw another secant line? We would have an intersection inside the circle. We could also have for instance, a tangent line that intersects at exactly one point, and we have a couple different options here. So a couple things happen, and we talk about like the intercept that we talk about. For instance, what is this particular angle? If we have, for instance, a secant situation, well, we could solve for that by doing a couple things, and let's get into it. So let's first draw another circle just so we can illustrate this better. Let's draw one off to the right underneath. And let's call this one C instead. Let's draw two different secant lines. And then we're going to actually highlight a couple different pieces. I'm going to highlight this first intercepted arc, or first arc, red, and this arc, blue. Okay? And then I'm going to mark this angle 1. Now, we could solve for the measure of angle 1 by doing something called the interior intersection angle theorem. It's exactly what it sounds like. We have an intersection on the interior of our circle. Okay, so we call this the interior intersection angle theorem. It's very, very obvious what it's trying to say. And what it states is the measure of angle 1 is going to be equal to, and for this red one, I'm going to put x degrees. For this blue one, I'm going to put y degrees. And it is the sum of those two angles times 1/2. So 1/2 angle x, or the arc measure of x, plus y. Okay, so let's say, for instance, let's put this in red. For example, let's say x was equal to 25 degrees. Y was equal to 31 degrees. Well, we could then say angle 1 is going to be equal to 1/2 times 25 plus 31. 25 and 31 make 56. And 1/2 of 56 is equal to 28. So angle 1 is equal to 28 degrees. And the one directly across from angle 1, the vertical angle to it, should also be 28 degrees. Okay, so there's your intersection angle theorem. If it's not an interior intersection, or if it's not an intersection on the interior, then it's on the exterior. So the exterior follows a similar process. Exterior intersection angle theorem. And a couple different options can happen. Okay, so for instance, we could have, I'm going to draw 3 different circles here. Carbon copy this. Oops. Copy, paste, paste. All right, so we have 3 different scenarios that could happen. Okay, let's just draw some centers. It doesn't quite matter. First option is what happens if I have a secant and a secant, where the intersection is on the exterior. Well, I'm going to call this angle 1 again. I'm going to highlight this big arc, red, and this small arc, blue. Notice one's definitely bigger than the other. So this is what we call a secant-secant intersection. So if we see 2 different secant lines where the intersection is on the exterior, then this would happen. We could also have secant tangent. Secant tangent, which is exactly what it sounds like. We could have a line that is secant or tangent, and another that is secant. And then I'm going to call this angle 1 again. The intersection is on the exterior. I'm going to call the bigger one, I'm going to label that red. And then I'm going to do the closer one blue. And for the sake of it, actually let's do this as well. Let's call this red one X, actually Y. Let's change it up this time. Let's make this Y, the bigger one Y, and then the blue one X. And then the other option is what happens if we have a tangent-tangent. So this is the third possibility. If you have a tangent-tangent, then you are going to have something that looks kind of like this. You're going to put angle 1 on the outside because that's where the intersection is again. And then once again, we have a big arc in red and then a small arc in blue. And then we could label these accordingly, according to the color. Red for Y, or the bigger is Y, the smaller is X. And then we have this scenario. In each one of these scenarios, the equation's still the same. No matter which one you have, if the intersection is on the exterior, you would follow this formula. The measure of angle 1 will always be equal to, still 1/2, but instead of adding them, we subtract them. Y minus X, or as I would prefer it, this would be the larger arc minus the smaller arc. It has to be in this order or else you get a negative, which is impossible. So it has to be the larger minus the smaller. So that's the larger minus the smaller times 1/2. Okay? So the measure of angle 1. All right. And that's all I have for you today. Okay? We have pretty much two new formulas. If it's on the, if the intersection is on the interior, then we use 1/2 of the arcs, the sum of the arcs. And then if the intersection is on the exterior, then we do 1/2 of the larger arc minus the smaller arc. All right. If you have any questions, please ask, and I will see you in the next one. Bye.